our final speaker now, Anka Reuel, and Anka is a computer science PhD student at Stanford who's affiliated with a Trustworthy AI research lab at Stanford, as well as the Intelligent Systems Lab. That's not the end of Anka's affiliations, though. She is also a technology fellow at Harvard Kennedy School, and in her copious spare time, I'm sure, is a vice chair for the EU AI Code of Practice. And so I don't know how Anka fits all of those things in, to be honest, but please take the floor.
Thank you so much. And yeah, as an add-on to Jimmy, I'm a vice chair for Working Group 4, and under my scope of responsibility fall whistleblowing protections and serious incident reporting, so thank you for the feedback on that. Today I'll be talking about something completely different, also not in my role as vice chair, but as a role as a researcher. I'll be talking about technical AI governance, and because I only have 15 minutes, a very specific problem within that, navigating transparency challenges in evaluations in particular. Brief reminder, AI governance, because everyone kind of uses a different definition. The one that I'm going with is processes and structures through which decisions related to AI are being made, implemented, and enforced. Which also encompasses rules and norms and institutions that shape the behavior of actors in the AI ecosystem. This can happen on an organization level, on an international level, on a national level, but it's kind of like the flavor of AI governance. And then technical AI governance is basically any technical analysis and tools that support AI governance more broadly by identifying the need for policy intervention, by informing governance actions, and by enhancing or broadening the scope of governance options that we have. Again, using technical analysis and tools. These are kind of all the different areas where technical AI governance can help. These are basically capacities that we would want or that we see in AI governance, going from assessment, which is also what I'll be focused on in today's talk, where we enable the understanding of system capabilities and risks to allow for more targeted policy interventions, or regulatory scrutiny, for example, I'll talk about that later. Access, where we enable external research and assessment of systems and the fair distribution of benefits of AI. Verification, which establishes trust in AI systems and confirms compliance with, for example, regulatory requirements, but can go all the way to guaranteeing certain properties of a system. Security, where we ensure the integrity, confidentiality, and availability of AI systems and guard it against misuses. Operationalization, where we kind of bridge the gap between regulatory or governance goals that we have and focus on the implementation and the practical realization of those goals. And then finally, ecosystem monitoring, where we enable anticipation of future challenges and identification of levers for governance intervention. If you're familiar with Epoch AI, where they kind of look at compute trends, for example, that's the type of work we're talking here. All of this basically came out from a report or a paper that I did with Ben Bucknell, who's also in the audience, who was the co-lead on that project, where we kind of identified, given current governance aspirations based on proposals, where we compared that to this technical state of the art and basically mapped out, okay, where do we actually have those gaps, and where do we need more progress on the technical side to actually support AI governance better. What we found was basically 89 open problems, along with more than 100 different research questions. That report is already out. So if you want to get engaged and help on that front, and are especially coming from technical background, I'll point you to that. Again, something that I want to focus on today is specifically the assessment part. Practical example here: AI benchmarks. A benchmark defined by Raji et al. In 2021 is a particular combination of a data set and a metric that is conceptualized as representing a specific set of tasks, and then is picked up by a community of researchers as a shared framework for the comparison of methods and models. Lots of words to basically say this. This is taken from Anthropic. That was taken from the Claude 3.5 launch. So normally what happens is when developers put out a new model on the market, they also report kind of model capabilities along benchmarks. So those benchmarks capture certain capabilities. Here we have, for example, MMLU, which is supposed to capture undergraduate level knowledge. We have others that are capturing coding abilities or like math abilities or like reasoning. And we have those like benchmarks for all different kinds of things we might be interested in model capabilities and risks. This is another example from OpenAI. So they kind of like all follow this like similar pattern where they just give you a table, throw a number at you for different benchmarks, and that's about it. On the other side, those benchmarks actually having a really like strong real-world impact, and their impact is actually increasing right now. So on the left-hand side is a quote from the EU AI Act, Article 51. A general-purpose AI model shall be classified as a general-purpose AI model with systemic risk if it meets any of the following conditions. A, it has high impact capabilities evaluated on the basis of appropriate technical tools and methodologies, including indicators and benchmarks. Then there's like a couple of other criteria that come afterwards, but this is the one we'll be focusing on. So as Jimmy mentioned, the EU loves to take risk-based approaches. And to do that, we kind of need ways to classify systems into different risk levels. One way of doing that is, again, using benchmarks. One of the biggest challenges we're facing right now here, especially from a technical perspective, is how do we know which benchmarks are actually good to do that? Because obviously, as you can see from this example, there might actually be really, really like significant consequences coming from that decision. So here, for example, it helps, like benchmarks help to classify whether a GPI model is considered to be one with systemic risk or not. There's other indicators you could use, but for the most part, like benchmarks and model evaluations are what people are focusing on. So you kind of want to be sure that you're choosing the right ones and they're actually doing what you want them to do. And this is basically the major point here. Benchmarks and evals more broadly only work if they accurately measure the capabilities and risks that we are actually interested in, meaning if they are valid. So this concept of validity comes from psychometrics. It's been introduced in the 1950s by Kronbach, and then a couple of other like researchers like Mesnick and Mehl discussed it, came up with different variations of it. But the key is like, does the measurement or like the evaluation that we're using, does that actually like measure what we wanted to measure? And then there's different kinds of like dimensions of validity. So this is basically what I just said. Construct validity is like where you have this abstract concept. So let's say, for example, bias, which can't be directly measured. So if you're interested in like whether a model is biased and want to create like an evaluation for bias, you kind of need to break it down into something that is actually measurable. And construct validity is about, do you do that breakdown in a way that makes sense? So basically, if you like have a concept, does what you afterwards measure actually capture that concept? Second thing, content validity. This one is more about coverage. So does the test cover the scope of the concept? Here, for example, let's take as a concept bias. If you're creating a benchmark for bias, you might not want to just focus on gender bias, but there might also be racial bias or ageism or like name bias. So there's all these kinds of like biases, and if you claim to have a benchmark that measures bias, you want to make sure that your scope like of the task that you're actually covering captures that. Or you adjust the concept, make it like more like smaller, and then kind of adjust the scope that way. But basically, content validity is about matching scope of the concept with your test tasks. And then external validity. How well does the result that you generalize, like from, how well does the benchmark result actually generalize to other contexts that are not like directly your test tasks or like maybe not directly reflected by your test tasks, but close enough that you can still get information about other contexts by using the benchmark that you applied. And these are only like 3 types of like validity that we see. There's so far I think I'm involved in like a working group where we're trying to like figure out what validity actually means for AI evaluations and what kind of validity evidence we would need for each of those. I think so far we have 9 different like validity types. So this is like a really like huge and like complex space that actually hasn't been like really taken into account in a lot of evaluation design right now. So for example, we have like predictive validity, whether we care about whether the results of like a benchmark on eval actually predict something else about like the real world that we're interested in. We have concurrent validity, where it's about correlating like the test with an already like known like validated standard. And it's like all like kinds of different like avenues like we can explore here. There's different cases where like some of those like types might be like some of those validity types might be more important than others. But for the most part, like these are the things we're thinking about when we're thinking about what makes a good evaluation. Kind of driven by the two questions: what makes a good evaluation, and how do we know like if like an evaluation is good or not, and what information do we need to assess that. I was involved in a project, or I led a project, Better Bench, which was also a NERV Spotlight paper this year, together with Chandler, who's also in the audience, where we kind of tried to figure out, okay, like what actually makes a good benchmark. And we talked to a bunch of people from like benchmark developers, model developers, users, like people in like governance, and came up with 46 best practices across the AI benchmarking lifecycle, and then scored popular benchmarks based on those criteria. These like 5 stages are design, implementation, documentation, maintenance, and retirement. For the purpose of this talk, I'm mostly focusing on design and documentation, because these are kind of like the 2 dimensions that are most important to understand. Is like, especially as an external person, is the evaluation that I'm looking at a good one? So design is all about ensuring those like different validity dimensions. Have I thought about like, have I defined the concept properly that I'm testing? Have I made very clear why I think, why that concept that I defined translates into the set of tasks that I put forth in my benchmark? And documentation is all about, well, documenting all the information in the design and implementation process so that other people can understand, did I take good decisions? Or like, did I take good decisions? That also, does this benchmark make sense for my like personal use case? And can I like use that like that evaluation like for the application context that I might be like want to look at? What we came up with was basically like we looked at like a bunch of like different also like very popular benchmarks, and found that unsurprisingly there's like a large like there's significant quality differences between those benchmarks. So we have on the y-axis, we have the usability score, which is for the most part implementation, documentation, and maintenance. So this is all about like how well can you use the benchmark in practice, and then the design score just equates to the design dimension. What we also found is that across those different life cycle stages, there's a like widespread like between benchmarks. So just like for interpretation purposes, like roughly like 15 is the best you can get. Like that you would get a 15 if you would score best like on like average score 15 if you get like full points on all the criteria that we put forth in that dimension. 10 is kind of like on average like you did okay, like you partially like fulfilled those criteria. 5 is like basically 5 and below is just like you did a really crappy job. And as you can see, like design is like and documentation are like okay, like on average, but even there we see a wide spread of benchmarks. And again, all those benchmarks that we looked at are actually being widely used in practice. And we're still seeing this like large spread between like in quality differences. Not even like starting like to talk about implementation, which is just really bad. There was a blog post in I think December 2023 from Anthropic, where they said like, hey, like for like some of those like benchmarks that are proposally like widely used, we literally had to like spend like or put like 3 to 5 full-time engineers from our team for like a couple of months to replicate those benchmarks and actually implement them, because the current implementations that are online aren't working anymore, dependencies broke, there's not enough information out there, which actually leads to a couple of other issues. Because if everyone has those issues, and even if they find ways around those issues, they're implementing the benchmark slightly differently, which also then again leads to differences in like the results, and the main purpose of benchmarks, ensuring that comparability isn't served anymore. Here are some of the like different criteria within that set. Again, it was like 46, so I'm not putting all of them on the slide. These ones are important for different types of like validity concerns. Again, is the like tested capability or concept, is it like properly defined? How is the tested concept or capability translated into benchmark tasks? And is that like properly, is the rationale explained? Again, this is especially important for construct validity, where we're interested in does the benchmark actually reflect the concept that it wants to test? There's like notions of what we want from a benchmark is also give the user of the benchmark some information, like what the score tells me. How can it be interpreted? In what situations, might it be more reliable versus in what, should I not use that result at face value? And a couple of others. And again, main takeaway here is we have a large spread across all those different criteria for each of those benchmarks. And again, we're talking popular benchmarks here that are being used by the large developers, that are being used within regulatory initiatives. I'll end here with two things. In general, validity comes into play at two different stages. So general validity is that notion of, for example, in the AI Act, where we use benchmarks without an actual application context to understand whether models are risky or not risky, or what they're capable of. But again, without knowing what the users will do with it afterwards. That makes a lot of those validity questions incredibly hard, which also makes evaluations at that stage really brittle to some extent, because we just don't know whether the tasks and the tests actually reflect what users are going to do with it. And then the second thing is application-specific validity. This is kind of flipping the whole game around, where we're interested in, for a specific use case that I'm envisioning as a user, does the benchmark tell me anything, or the benchmark result, or the eval result? And for both of those, we need sufficiently transparent evals and benchmarks, and actually information about how they are being created, and what design choices went into them, what implementation choices went into them. And this is exactly what we don't have today. As you've seen in the blog post from OpenAI and Anthropic, it's mostly just a table being presented. Even if you Google for the research papers behind the benchmarks, there's oftentimes a lack of information, design choices that we're missing to actually understand, is that a good benchmark? And is that a good benchmark for my specific purposes? Because right now, again, as users, we can't really decide which evaluations are good, which evaluations are good for what I want to do, and hence we have this kind of big information vacuum about what models can actually do. And it's not only about those kind of the risks that we're unaware of and the things basically what we're evaluating, but we're actually really, really unsure from a technical perspective on how we should evaluate those models to actually get those information and know that the information, is a model risky or not risky, is actually reliable and right. Thank you. Actually, if you can go back to the slides. Sorry. Because there's some upcoming work on both of that. One is on human baselines, which are actually being used quite frequently in evaluations because it gives us a good reference point, as basically if you compare to human performance. But oftentimes this is actually just being thrown at us as kind of oh yeah, we have this human baseline here. But the way how you design the human baseline is equally important. Am I comparing against experts? Am I comparing against regular, basically normal people? What is kind of the population? For what population is the evaluation valid? This is all things that we explore in a new paper that'll come out, I think, in a week or two. Trish is also, I think, in the audience, one of my co-authors. I think I saw her earlier. And then the second one is understanding validity evaluation and validity evidence in AI. This is part of the research group at Stanford. I'm part of the Stanford Trustworthy AI Research Validity Reading Group, where we're trying to really break down what evidence for each of the different validity types do we want to have in model evaluations to actually decide, are they good? Now I'm done. Thank you.
Oh, it's a very clever way of getting 2 rounds of applause. So I think we got a question over there for you first.
Is this working? Yeah. So what are the best practices or different approach to prevent or at least circumvent that the model being trained on the benchmark itself?
Good points. So basically what you're pointing to is the issue of data contamination of evaluations. It's a tricky one. So I think like one option is to just have like more private benchmarks or like private holdout sets. Obviously it's kind of like on other like ends like unsatisfactory because, well, then we don't have any like insights into those evaluations themselves. There's other options like a globally unique identifier that could be attached to the benchmark items and the benchmark itself. And then you can think of kind of like a database of those like globally unique identifiers that, for example, model developers could basically filter through in the database, which again obviously relies on the issue of we need model developers to kind of be on board and not want their models to be contaminated, which unfortunately isn't a given because if your benchmark is, or like if your like model has test data from the benchmark, it can artificially like inflate the results and make them look better than they are. So in some sense, it's not in the interest of model developers to do that. A third option is having specific test tasks within the benchmark that check for, hey, have those test items been like included in the training data? But unfortunately, the bottom line is we don't have anything robust. But what we can do is kind of like using all those different approaches to tackle the issue from different.
I'm next, I think. Hello, everybody. Thanks very much for the talk, Anka. I was just wondering, why isn't there some sort of centralized benchmarking service that, you know, does all of these things and then reports it out with all this information? It feels like, yeah, it sort of feels like an obvious thing. So I suppose I'm wondering why that hasn't been developed or what I'm missing.
Do you mean a benchmarking service that actually designs those benchmarks?
Oh, yeah, sorry, I mean something that would do the benchmarks on behalf of all of these organizations or on the behalf of a client.
So we have some implementations on that. So for example, there's the LLM Harness who's trying to achieve something like this. We also have Helm. There's actually a new version of Helm coming out. So this is like from Stanford, like a project where they basically like benchmark models against different benchmarks and like try to be that like central repository. There's a safety version of Helm coming out soonish, or has been out. Actually, I haven't followed that, where they do the same for risk and like safety benchmarks. So we have all those like different approaches where people are trying that. But as again, like as the Anthropic example showed, there's a lot of like different. It takes a lot of time and capacity. And what you would want is actually like an independent actor doing that. They are unfortunately notoriously underfunded. So especially like universities, like we have like engaged students who are doing that with Helm at the moment. But in an ideal world, we would have that more like central like service and system. The other kind of avenue for that are external like independent tests. And this is something where we're seeing a nascent ecosystem and where I'm hopeful that initiatives like the Code of Practice can actually push for like a more like broader like adoption of that.
Well, thank you very much. I was very pleased to hear that you also consider uncertainty quantification among the requirements. It was because I think that is key for the validity of those benchmarks in many sense. So I was just wondering if you can tell us which of those benchmarks actually go beyond a certain level of validity in terms of uncertainty quantification, if there are at least some that achieve that level.
I would need to double check within the data, like which ones are actually like, especially on that specific criteria, which ones are good. But in general, I agree that that's like, honestly, to me, that's like so striking that we don't do that, because that's literally statistics 101. Like report your like statistical uncertainty with a result, and I honestly, I can't believe that we still don't do that. And then we have like blog posts like the one from Anthropic or like the paper that came out that basically said like, hey, we should do this, like, and everyone celebrated it, and it's like, yeah, we really should. Yes. So I think like the benchmark developers are picking that up more and more. I'll refer you to the Better Bench paper, because there we also report all the different criteria, and also the Better Bench website, which is basically attached to the paper, because we have a repository of all benchmarks that we tested, the criteria, and then you can basically look at each criteria. But unfortunately, as you've seen in that one graph, that was one of the lowest scoring criteria, actually. I think out of the, if I remember correctly, out of the 25 benchmarks we in-depth analyzed, 4 did it? 5? Nope, not at all.
Hi, thanks for the talk. This is a slightly broader, more out there question, so no worries if there isn't an easy response to it. But one of the things that struck me was it's quite rare to see parlance coming from psychology and psychometrics, like construct validity, etc., co-opted into this framework within machine learning. But also it's a little bit of an obvious thing when you think about it, that construct validity, face validity, etc., always would have made sense. And my question is, in your work, this work specifically or more broadly, have you found other kind of social sciences frameworks were particularly useful, less useful, etc.? I guess just the question is really cross-pollination from other fields. How are you finding it?
I've been pushing a lot for that, because I think notoriously we as computer scientists have been doing not so great of a job with working with other fields. And we're kind of trying to reinvent the wheel every time when there's actually really good work happening in other fields as well. And especially as AI is getting adopted in so many different fields, we can actually learn a lot from those other fields, how kind of impact mechanisms work, how causal mechanisms work. To your specific question, so right now, a lot of my work focuses more on the psychometric side of things, measurement theory more broadly, and we're engaging with those communities as well. On my governance work, there's always a lot of work with policy people, with national security, history a lot as well. So I'm trying to make those connections happen. And more broadly, I feel there's almost no subject where we can't adopt some idea from in the AI context. Again, just because AI touches on so many different things these days. I mean, we have biology, we have biorisks that are being discussed a lot. And then we kind of have those bio evals, and then oftentimes, and this is one of the criteria we set out in our Better Bench framework as well, is that kind of oftentimes those evaluations are getting designed, but without that input from domain experts that we would actually need. And then you kind of have 5 computer scientists to sit together and think oh, this is how it should look like, and it's my version of biorisk, but never really talk to a biologist about it. And I think these are the things we urgently need to change within the research community and actually have those pathways to more collaboration.
Okay, you get the final question.
Yeah, thank you. Because I want to ask a question to the room, just to make sure, because I get worried when I see the language of scientists, or many scientists here. So if you are interacting with a chatbot, and the chatbot generates the following sentence, "I will kill you," how many will be scared? I want to know. 1, wow, 2, 3, 4. I'm getting worried. They don't think, they don't lie because they don't know the truth. They don't have any intention. I mean, whatever we train on these things will generate things that look real, but they are not real. They are imitations. So I'm worried that we are using the wrong language. And we should, if we don't use the right language, I mean, what do we expect from people that don't understand AI? This is just my comment, because I think there's a problem here.
Let me respond to that really quickly. I think it's one thing is about basically giving or pretending or phrasing things the way that those models have intention, but for a lot of risks that is actually kind of secondary nature, because someone might see that statement and be scared, or you could also throw it around and be the model tells you to kill yourself or whatnot, and then you have a user response to it. And a very human reaction to it, and or maybe a user reacts to that statement and takes actions.
Don't misunderstand me. I'm with you. So but what I'm saying is that we are the problem, not the machines.
When you say we, can you clarify?
Humans. I mean, If we train a chatbot, and I know very well the case of Character AI or the previous one in Belgium and so on, if the chatbot answered that, it's because we trained the system to, sorry, they didn't answer because they don't answer because they're not humans. If they generated that, it's because we trained it in that way. So it's not a human being. It's not a living thing. It's just an imitation of us that makes people believe that they are real. And this is part of the problem.
I agree that that's where we, and maybe like Neil also has some thoughts on that.
I have many thoughts on that.
Okay, I thought so. Do you? Okay,
If you can have a sentence, Neil, but we need to wrap up soon.
People are currently training agentic AI systems, not just chatbots, that go into the world and take series of actions.
I said the chatbot, right? I mean, I said the chatbot, not an agent. I was very careful on that. I said the chatbot, not an agent.
In that case, my second sentence is, I'm scared of agents.
I hate to cut off such an interesting conversation, but we are almost at time. But obviously great to have these conversations continue during the coffee break outside, and then we'll be reconvening in the room next door, CC 9 to 13. It's secretly 3 rooms connected for our final plenary remarks, followed by closing remarks from Stuart Russell. So let's thank our speakers once again.